Alright, hello everyone, and welcome back. Today in this part of the video, we'll be discussing memory hierarchy and then explaining the purpose, what it does and how it functions in the hardware, and the overall function of it. If you're ready, let's begin and get started, okay? So we have here, what is memory hierarchy? So memory hierarchy refers to the organization of different types of memory in a computer system. So instead of only using one type of storage, the computer uses several layers of memory that work together to balance the speed, the storage, the size, and the cost. So each level plays a different role in storing and accessing data. So this design allows computers to keep frequently used data to close the CPU while still maintaining the large storage capacity for the programs and the files. So by organizing memory in layers, the system can run programs efficiently without slowing down when large amounts of data are involved. Alright, so now we have like the levels of the memory hierarchy. So this is basically going to be an overview of it. So the memory hierarchy is made up of several levels that store data at different speeds and capacities. So these levels include things like registers, cache, memory, main memory, the RAM, and then secondary storage such as the hard drives or like our solid state drives. So each level is responsible for storing data depending on how frequently it is used by the processor. So during program execution, the data moves between these levels depending on what the CPU is going to need. So frequently used data is stored in faster memory so the processor can access it quickly, while less frequently used data remains in larger storage devices until that is needed. Okay, so now we have registers. So registers are the smallest and the fastest memory units in a computer system. They are located directly inside the CPU and are used to temporarily store data that the processor is currently working with. Because they are built into the processor itself, the registers can be accessed almost instantly. So registers also play an important role in executing these instructions. So for example, when the CPU performs a calculation, the values involved in the operation are often stored in registers before being processed by the arithmetic logic unit, which we discussed in our previous video. Alright, so next we have the cache memory. So cache memory is a small but extremely fast memory located between the CPU and the main memory. Its main purpose is to store frequently used instructions and data so the processor can access them quickly without needing to retrieve them from slower RAM. By keeping commonly used information closer to the processor, the cache memory reduces delays during the data access. So this will allow the CPU to spend more time processing the instructions instead of waiting for data to be retrieved from the main memory. Okay, so now we have the main memory, the RAM. So the main memory, also known as random access memory, RAM, stores programs and data that are currently being used by the computer system. Unlike registers and cache memory, RAM has a much larger capacity but operates at slower speeds compared to those components. RAM is also considered volatile memory because its contents are lost when the computer is powered off. Despite the limitation, though, it plays a critical role in system performance by allowing programs and data to be accessed much faster than secondary storage devices. Okay, so now we're going to be talking about secondary storage. So secondary storage refers to the storage devices that provide permanent data storage even when the system is powered off. Examples can include things like SSD, which is a solid state drive, a hard disk drive, which is an HDD, and external storage devices. These storage systems offer a significantly larger capacity compared to primary memory. Although these secondary storage devices are slower than the registers, the caches, and the RAM, they're essential for storing operating systems, applications, and like user data. Their large storage capacity makes them ideal for long-term data retention in computer systems. Okay, next, we're going to be talking about how cache improves performance and just cache in general. So cache memory improves the system performance by storing frequently accessed data closer to the CPU. So then when the processor needs data, it first checks the cache. If the data is found, this is called a cache hit, and the CPU can access it quickly. If the data is not found, though, a cache miss occurs, and then the processor must retrieve the information from slower main memory. But this process allows the CPU to avoid unnecessary access to slower memory components. Um, this will then significantly reduce data retrieval time by optimizing how data is stored and accessed. Cache memory plays a crucial role in improving the efficiency and also the speed of modern computer systems. Alright, now with that, we have reached the end of the video. I hope this was helpful in teaching you more about the memory hierarchy and the details about it and how it serves to function in hardware. Please feel free to like, comment, share, and subscribe, and stay tuned for the next video. Thanks.